So I've been missing in action. I decided to finally take the number theory course, which really got me out of shadowboxing, which is great. I have a plan for some videos that I want to make from the problems that we covered for the first exam. So I'm actually past the first exam in the course. Got a lot of materials in here for all the homeworks that I've submitted in the exam itself. And then the actual notebook where I keep all the materials, I log when I do the lectures, the videos. I watch the videos. By video number 16 right now. I log in what date I take it at. And then, of course, there's your usual following of the lectures, either from content in the book or content in the videos. So I log, which video it is. And that's been going pretty well. Watch the videos, go through the book, write notes. Of course, there's content that I've already covered when I read Rosen, but it doesn't hurt to do it again. And then, of course, run through all the problems in the book. And if I encounter any issues with them, I write it to the teacher, write up the problem. She's been pretty good. She's been able to give me a lot of feedback. Of course, I'm not as good at proofs as I would like to be. It's going to take me years to get there. So that continues to be my weakness. But when it comes to calculations, I've been doing pretty well with those. So at least the calculations, because I taught myself in Rosen, and I'll show a lot more about that. But yeah, for example, and I think it's just crazy that I read all of Rosen, and only near the end did I figure out how to invert a Euclidean algorithm problem, where you start from the 21, for example, 21 is the GCD of 441 and 1155, and you take 21 and you make it equal to 63 minus 1 times 42. Then you take that and you put in 42 in there. Then you put in 63 as 168 minus 105, and you keep going up the chain until you get something that is an equation that says 21 equals a factor times 441 plus or minus a factor times 1155. So it's crazy that this is what happens when you self-teach. I've also included a couple of handouts, things that I've come across in the problems that are interesting, just to add additional learning. Gone through the homeworks. Again, some of the proofs have been easier than others. The calculations have turned out to be mostly okay. Yeah, so there's your chapter 1. With some errors, not perfect. I still need to get better at this number of divisors for specific numbers. That divisors from 1 to 500 that are 500 divided by 3, divided by 2, divided by 7. Primes. And I need to get better at that. It's just a set theory problem. Need to get a lot better at that. Messed up the harmonic series problem proof in the course. I just didn't get it right. I worked at it pretty hard, but I didn't get it right. So I'll have to figure that out. But yeah, I love the course. It's filling in a lot of holes. I'm getting a lot of feedback for my work, which is really why I took the course. And it's not shadowboxing. It's definitely a real course, getting my butt kicked. My first impression in the course was just, I was really just terrified, really. I think the word that I would use is terrified. But I'm no longer terrified. I'm more in the stage of like, okay, I've got my rhythm. I already completed the first course. Of course, because it's digital, you have to figure out how do you do your submissions. And so I've been able to figure that out for a first cycle all the way through a first exam from 4 homework graded. And then some input from the teacher. So yeah, it's going really well. I'm really loving it, and I'm really glad that I'm taking the course. I think in any endeavor in life, it's great to just throw yourself in the deep end of the pool, and that's what I've done. And so yeah, it's going great, and I'm having a lot of fun. I'm learning a lot. Some Chinese remainder theorem. I finally learned how to do the Chinese remainder theorem with the normal x equals b sub I, m sub I, x sub I, all added by the various m's and the various x's and b's. So I finally know how to do that. I was relying on the what I call a dirty method from Rosen that always seemed to work for me, and I've been using it. So actually in the exam there was a Chinese remainder theorem problem, and I was able to do it both ways, and I could figure out that I made a mistake in one of them, so I was able to get it right because I double programmed it effectively. Then all these p to the q problems, I got 2 primes, and you do all your equations for q to the p to the q. I've learned how to do some of these proofs. I've done them correctly. There was one that I had a problem with, and I asked the teacher. She helped me, and then I figured out, yeah. So just learning tricks of the trade, really. That's what taking a real course is about. Yeah, that's what this is all about. Yeah, more material. I took the practice exam, learned a lot from it. Interestingly, one of the problems in the practice exam was very similar to one of the problems in the exam, where you take and you figure out the d of the greatest common denominator between 84 and 49 is some number that does not divide 5. And so, of course, there are no solutions. So this type of problem is really easy because you look at it, you do it, you don't have to do it, and you move on. So that was really good for the test. I really like that. They gave you the solutions for that practice exam. Yeah, so that's the content so far. And then, of course, I overflowed this notebook because when I add all the assignments to this notebook, it'll be like really full. And then I sat down and I did many problems for the test. I spent a whole week doing problems before I took the test. And of course, I have a full-time job. The whole week, like at times really early in the morning, 5 in the morning. Did a bunch of Euclidean algorithm problems. Started timing myself, figuring out how long it took, and then mapping it. And I realized that if I screwed up a problem, it would double my time during the exam, and that was bad. That did not happen during the exam, but it happened during my practice. And so I learned, as I did more problems, to be more systematic, very careful, to get the problem right the first time when it was a calculation. And so that I really worked at hard. Did a bunch of problems from Burton, from Strayer, which is a book for the course. Went back to Rosen, did a few more problems in Rosen that I had not done. Checked out Nevin, but the Nevin problems are more advanced. And so I just use Nevin just to look at, okay, this is kind of like what happens with problems when they get really hard. For example, this is a Burton 234, chapter 2, section 3, problem number 4. So I did a lot of Burton problems, learned a lot from them. That was pretty good. It's a great compliment to Strayer, especially since I hadn't done Burton before. So now I have 3 books from which that I will rely on to study for the exams. Tons of problems from all 3 books. By the time I got to practice for the exam, I had already done almost all the problems that out of the chapters out of Strayer. So it was really more Burton. Tons of easy problems from Burton that were really useful, and then a few from Rosen that I hadn't done before. Then I came up and I made up all these gigantic, very difficult linear congruence problems or modular arithmetic problems that were never going to be in an exam. They're so hard, and I did them. I timed myself. It took 19 minutes, 14 minutes, 16 minutes, and then I finally got one right, and I was like, oh, great, okay, good. And as part of learning, I realized you have to be very systematic and go step by step, and sometimes even do the product twice. And then also one thing that I came up with, see how I just kept making mistakes left and right, was until finally I got one right, al fin, at last. So I got one right, it took me 10 minutes, and so I learned if the mod is large, the first thing you do is you do a multiplication table of the mod. And that way, when you're doing your calculations, you're referencing that number instead of having to do it every single time in every calculation. That really, really helped. And then, of course, in the Euclidean algorithm problems, another trick that I did was to check the value every single time. Every single time you complete a problem, a step in the problem, you check that this number equals 17. every single time. Every single time you do it, you go into the side and you say, okay, am I still getting 17 from this product? Because sometimes when you substitute the value, you screw it up and you're no longer getting the GCD of 17 that you should by the difference between the products. So that's very key. That's key to doing an Euclidean algorithm problem successfully. So yeah, I did a whole bunch of these, got better at them, and that really helped me in the exam, of course, because I got the ones in the exam correct, the calculations. So yeah, more problems, more problems, more problems. Then after I did all these problems, I did a total of 152 problems. I asked the teacher for some of them that I didn't get right. She helped me with those. That was great. Then I did a proofs practice. Went through some of the proofs. Then I did additional problems. Just like, okay, let's do a few more, even more. And then now, of course, I've already begun chapter 3, which is material that's going to be in the third exam. So that's where I am with number theory, taking a real course, getting my butt kicked, learning a lot, and it's been wonderful.